Hello everyone, this is my Pedal Builder reacts to the Marshall Vintage Reissue Blues Breaker. And we're going to also, bonus, do a unboxing video. So here we go, sort of in the sleeve thing. Just like that. And we have this internal coffin. Very nice. Opens up like this. Now I have opened this and played with it a little bit, so if you see like oils and things, that's from my own hand. So we're gonna take it up, and then I'll try to not take it apart because TV magic already took out the screws. But here it is. Here's the reissue in its full glory. I'm having a hard time finding any differences externally to the original. Really cool. Alright, so inside this battery thing popped out. Ignore for now. We have a little booklet and these cardboard things. It actually does seem like it holds it nice in place. As you can tell though, the knobs are kind of holding the top, basically pressing this down. Not too crazy about that, but you know, as long as it made it safely to the owner, new owner, or old owner, or new used owner, sorry. So inside it's got a bunch of stuff. I'm not sure if this is one for one of the original Blues Breaker, but there's a little pamphlet. Alright, here we are. The battery compartment did fall out only because when you dismantle, the way it kind of holds in here, goes like this. So if all my screw holes were lined up, this stays nice. You would do something like this. You'd push it and then it opens up. Ooh. And then here's your 9-volt battery held in place with some foam to pressure it. And there's your little battery clip. I don't know if this is an upgrade to the original, but this battery snap seems like it does pretty well holding the battery in. So just to demonstrate it, feels pretty solid. I like the solid body battery clips just because it's a little bit more to hold on to. Sometimes you get the little flimsy ones and it's just that, they're just flimsy. So not cool when those are used, but this is a good one. I'm gonna just put that in here for now. Let's talk about the foot switch action. Feels really solid. I know because I've taken it apart and looked at other gut shots that it's a double pull, double throw. One thing I noticed is that, look at the little top hat on this. It's a little tiny. It's a little smaller than I'm used to. Not that that's a bad thing, but because your foot is only going to touch so much. But I just thought that was an interesting little find. So if you use any of those like foot switch top hat things that you put on, just make sure you get the ones with a set screw. All right, these pots feel great. They are nice and tight. They're not going to move around, like even if you go like this. I'm just getting a little traction because these knobs are kind of like rubberized. But other than that, like if you're not gonna vibrate those into new settings, which is gonna hurt your tone. But yeah, they feel great. Let's take a look inside. Oh, there's a bunch of other things here. Do not open. Did I just void a warranty in front of everyone on camera? Probably. Here we are. Now, I compared a lot of pictures, gut shots, and it looks like they've even gone as far as to use the exact same circuit board printouts. These are one layer PCBs. So there's basically just copper poured on one side and there's nothing on the other. That's kind of why you can kind of see through. It's a little translucent like that. One thing I noticed right off the bat is the use of metal film resistors. These are metal film, they're 1%, and that's cool. But the original uses carbon film, which is 5%, which does make every unit, you know, more likely to sound a little different than the other. And don't forget, pots pretty much are always 20% tolerance in here. So, you know, I guess all those things combined, you're going to have the original 90s Blues Breaker deviate a little bit from each other in that regard, compared to this, which is going to be a little bit more streamlined. Now, the theory, I'll just rehash for some folks. The theory about metal film versus carbon film, and that's tan versus what you see here, is the metal film is tighter resistance, or tighter tolerance, and they are theoretically lower noise floor. And that's that. That's all I gotta say. Some people say carbon film's the mojo. Some people say that metal film is the mojo, and they'd prefer having lower noise floor than the 0.001% mojo. I'm just making that number up. I'm not sure if that's real. Yeah, so we have an axial, this is kind of funny, an axial capacitor. This is basically for the bias of the op amp, or the 4.5 volts. I think it's 4.5 volts. All right, so the jacks here. Let me see if I find my little jack. I know I got one here somewhere. According to Marshall, I think via a source that talked to Marshall, is that they improved these jacks. Now, it was funny when these were first starting to come out of the woodwork. Analog Man Mike commented, he's like, well, I better stock up on my jacks because I'll be fixing a lot of these. And then kind of Marshall, I don't know, I gotta look it up. I'll put it here in the video if I find it. Said that they made the jacks a little bit better, so that's not going to be a problem this time around. Use of ribbon cable, I understand it's part of the original. That can be a little dicey from having issues and repairs. But as far as these jacks going in and out, it feels solid. I don't think they're going to, that will definitely not pop out at all. So, really cool. It's almost like it has a double catch in there too, so it kind of catches once and then catches twice. So if it does fall out, I don't think that would ever happen. But it's a little loose because I hand tighten these for demonstration purposes, but you can see they're nice and tight. The threads are plastic, so we'll go ahead and do that. Check that out. So just don't go cranking on these Hercules, all right? See, they're plastic threads, but they actually are kind of like a harder plastic, which feel really good from tightening down and just overall threading of the nut. I think that was my nickname in college. So before I do that, I gotta take out more things to do a removal. I know I don't have my real tool in front of me to take these off. Ooh, you know what I'll do? I'll use my IC puller. There we go. Nice and tight. So these are gnarled on. Looks like maybe there was some glue. Huh. There we go. There we go. All right, going to use these 3D printed rocket sockets by my friend Chris Pearson. Thank you. Man in suit, otherwise known as the Man in Suitcase, and you might recognize his Instagram handle if you're in the same circles as me. He's the one with the Stormtrooper icon thing. All right, so these are cool. Nothing too crazy at the moment to talk about. Maybe you and I can talk about the weather during this period. We can play, I Spy with my little eye. All right. So another thing is that this foot switch is directly attached to the circuit board. Not bad. I'm not too crazy about that, but I will say that I don't think that that's going to be a problem with this design because this is really solid here. This actuator for this foot switch is really kind of all the bulk of that pressure is being absorbed by this metal. So I don't think that any of that stress is being transferred to the foot switch. So good, good, good. All good things. Good construction. I guess if you're going to model something, the 90s might be a decent place to go. All right. One more. Got to take out this foot switch. All right, so I think it's kind of neat. You're going to see here, I usually have to throw these out, but it looks like Marshall made it part of the design. But see this washer that sort of has this little ring to it? It's a little locker. So, and then there's a hole in the chassis to kind of work with that. And as well as you look here, there's a keyhole on the actual foot switch itself. So when the technician is putting this pedal together and they're, you know, torquing it down and whatever, that ensures that the that this basically is not going to rotate when it's being torqued down. All right, so let's take this thing apart even further. And this is heavy, by the way. This is super heavy. I mean, I could bend it a little bit, but I don't want to go too much further, but it's definitely heavy duty. All right, here we go. Here's the inside, and I'll zoom in a little bit. All right, so here you go. Here's all you people who like to reverse engineer circuit boards and things like that. Here's your gut shot. So what's interesting here is the tone pot. I didn't realize that was an R22K. I don't think that that's a common value, but I'll follow up on the video. And see here, this is cool about these pots is that they actually have their body soldered directly to ground. So in theory, you know, that's sort of acting like a shield. Very cool. But also, since it's the body is being soldered directly to the circuit board, it's adding some rigidity to that. So I really, really like that. That's cool. That is super cool. I don't really see those with aftermarket circuit boards. Again, I'm going to assume that that is the same PCB files as the original. What I did notice when I was kind of messing around with mine, and I don't know if this was I don't know what kind of solder they used back in the 90s, but I noticed that there was some touch-up done on the solder joint here. It looks like a little cold. And this is one thing I hate about single-layer circuit boards, is that, you know, it's not really great for through-hole components. I mean, it does the job, obviously, but I like it when there's plated holes so it grabs onto. So when you do some rework or add some more solder, sometimes it can come up like a bubble, like you see here. So this is, again, done by the factory. And check this out. There's like that solder joint is open right there. There's a little hole. It's not open, like there's still connectivity on the other side. But after this video, I'm going to hit that with some of my solder here. And only use the best. This stuff. So I'm going to hit that up there and also there. And look for any other solder joints that didn't get fully. The hole isn't completely surrounded. But here's something I want to talk about. So some of you might have seen my picture comparing the Make 1 and the Mark II. Mark 1, Mark II. So basically, not Mark 1, Mark II, but like Make 1 V1 and Make 1 V2. There was some rumors around the internet, basically was where I got that information from. Besides like Aeon Electronics and General Guitar Gadgets, and a few other places talking about an early version and a later version. And then specifically I believe the later version had 47 picofarad, or the earlier version, or basically C3 here. R1 and R2 were different. So R1, R2, and C3. The interesting thing, though, is that I've never seen a gut shot of the Mark 1 V or Mark 1 version 2, the revision 2, 1.1, 1.2, I don't know what you want to call it. But I have never seen C3 be anything other than 10 picofarad, and the same with R1 and R2 being the original values. I really don't know the 33K and then 27K. I don't know what that's rooted in. I would love to see a picture. So if you have a picture of a Mark 1 revision 2, please send it along. I'd love to take a look. But anyway, here are the pots. A100, B22K, A100K. Yeah, so inside we have more metal film resistors, basically metal film resistors all the way across. These appear to be like MLCCs, but axial. The footprint is exactly the same across the board, as you can tell. Very, very clean. 1N914s, I believe, if my memory serves me correctly. The chip is a Texas Instruments TL072 CP, just like the original. So, all in all, I don't think there's really going to be any tonal difference. I think some people might have a problem that they chose metal film over carbon film. I don't know. I built one of these a long time ago with metal film resistors, and it's my favorite overdrive, so I'm not too worried by it. And we have the LED that's on a stand. That's cool. I mean, yeah, really, I think they really did a great job keeping in line with the original sort of design. I mean, even going down to the circuit board traces are the exact same length and runs. Oh, before I finish up on this, it's funny because it's viewed that the schematics you see online of the Bluesbreaker Mark 1 revision 2 is that they all seem to cater C3 to be 47 picofarad, when clearly it's a 10 picofarad. And then you can sort of confirm this because here's your IC, and then, you know, it basically jumps between pin 1 and pin 2. Here is the capacitor right here. This run goes up pin 1, and then this run, where is it? Yeah, this one goes, well, that goes to pin 1. Then the other, no, that one goes to pin 1. Oh, this one goes over here, down, and around to pin 2. Okay, so that's a 10 picofarad. I don't know where all these guides for clones come up with using a 47 picofarad, considering that I've never seen a gut shot with 47 picofarad here. And it's supposedly the standard usage. And I even went and looked at the schematic for the version 2, kind of that silver box Bluesbreaker, and this circuit is completely different. So there's no translation or no error in that regard. So again, I don't know why this is considered to be standard at 47 picofarad, when clearly it is not. Maybe I'll make my own version of it and be able to toggle between the two. Stay tuned on that. But yeah, not much more to say. Everything's the same. If you like what you see, subscribe. If you don't like what you see, send me a comment. Let me know what I can do different. Talk soon.